Hello, my name is Renee Cornell, and I'm one of the engineers with WSP on the Gerald Desmond Bridge Replacement Project. WSP serves as the PMCM on this project. This project is located in Long Beach, California, and will connect the 710 freeway to Terminal Island. This project is very unique to California, as it will be the first vehicular cable-stayed bridge, as well as the first time a movable scaffolding system is used. The Gerald Desmond Bridge Replacement Project, or GDB for short, is a design-build project with an estimated program cost of $1.5 billion. This project is funded by the Port of Long Beach, United States Department of Transportation, Caltrans, and Metro. I'm currently standing on one of the 515-foot towers. As you can see, the size of the project is incredibly large. The size of the project is approximately 1.5 miles. When completed, the project will have 6 lanes and a 205-foot clearance above the existing channel, and will be an icon for the city of Long Beach and Southern California.
Hello, my name is Matteo Diorio, and today I'll be talking about the main span bridge. The main span is a 3-span cable-stayed bridge approximately 2,000 feet long. The center span between the 2 towers, one of which I'm currently standing atop of, is about 1,000 feet. The 2 back spans between the towers and the end vents are about 500 feet each. The superstructure will be made of steel framing with approximately 600 precast lightweight deck panels. None of the superstructure activity has started yet in terms of the erection process, but the deck panels have started passing. The superstructure will be supported on 80 cables emanating from the 2 towers. The towers are 515-foot tall, reinforced concrete, hollow, octagonal, modern marvels that will completely revolutionize the downtown Long Beach skyline. The towers are supported on concrete footings as well as 12 cast and drill pole piles. In addition to the towers, other substructure elements include 4 end vent columns. These end vent columns, 2 are on either side of the channel, and these are also supported on concrete footings as well as piles.
Hi, my name is Jovian Santiago, and we're here at the Gerald Desmond Bridge. We're standing on what we call the west approach side of the bridge. Here we have 2 lines that are running parallel to each other. As you can see, here we have an area where cast in place took place for 2 spans, and then we can see the transition as we move towards the MSS section. The west approach has 114 CIDH piles, as well as 27 pile caps and 35 columns. Each line itself has 14 spans. As you can see, this is the north line, what we call it, and the south line. This one goes westbound and the other one goes eastbound. So here we can see that because we're near traffic, we had to use cast in place, and that's something that goes throughout the entire project where we have a lot of traffic or we go over railroads or anything near traffic. We tend to use cast in place, and as we get further and higher from the ground and further from the road, we transition into what we use for the MSS. It's typically straight spans, and each span consists of about 215 feet. So if for 14 spans, we can equal that to about 3,300 feet total for the west approach. Alright, so we're here on top of the westbound lane for the west approach here. As you can see, this line has been fully finished, besides the final touches for the grinding and other roadway stuff. On my left, we have the south line, which is currently being constructed. As you can see, this is where the MSS begins. A little bit difference between the north line and the south line is that the north line has a typical box girder, which includes only 2 exterior girders, no middle girders. And the south line has 2 external girders with 1 central girder. And it's a little bit wider because it also has a bike lane, which is about 8 to 10 feet wider, making this have a bigger span. So here you can see on the south line what I'm talking about for the girders. We see one exterior girder, we have a central girder, and then another exterior girder. Here, contains only an overhang, while the south side has the bike lane, where you can see is a little bit wider than this side. And then each span basically contains 2 bays as you move forward on the south lane, and then 1 bend cap at the very end. Right now they just have poured the stem and soffit concrete. They're currently working on getting ready for the top deck. So here we have at the very end of the span, you can see what they're installing in some forms called the lost deck. Essentially, it's the formwork where the top deck reinforcement and concrete would go on.
Hi, my name is Ignacio and we're on the east approach of the Gerald Desmond Bridge. The east approach is comprised by two main structures, the westbound and the eastbound approach. The eastbound line approach is comprised by 6 frames with a total length of approximately 3,800 feet. The eastbound approach is comprised by 5 frames with a total length of approximately 3,700 feet. Both the eastbound and westbound approaches combined include a total of 188 CIDH piles, 44 pile caps, and 63 columns. The superstructure consists of post-tensioning concrete cast-in-place box girder. The two westernmost frames of both the eastbound and westbound side have been constructed using the MSS, you can see behind my back. Currently, the westbound approach has been completed and SFI has lowered the MSS and is working on the heavy lift operation to turn it around and lift it to construct the eastbound approach.
Hello, my name is Daniel Ramos and I am one of the engineers with WSP at the Gerald Desmond Bridge project. All of the superstructure frames that are not being constructed using the MSS are being constructed using traditional cast-in-place on falsework system. These cast-in-place concrete box girders can be built with different types of traditional falsework such as with timber, PAFCO towers, and even pipe columns, which all have been used on this project as of today. These cast-in-place superstructures are built from the ground up using temporary structures such as concrete pad footings, steel pipe columns and I-beams, timber soffit joists and panels, and timber exterior girder and overhang formwork. Unlike the MSS, all of this temporary falsework needs to be built from scratch, stay in place until the entire frame is poured with concrete and post-tensioned, have the falsework removed, and then move on to erecting the next falsework for the next frame. So currently, they're working on frame B5, which is cast-in-place superstructure, and in the background we see frame B4, which is also a cast-in-place superstructure, which will eventually connect over a roadway, Pico Boulevard.
Hey, Mateo again here. I'll give you an update on the current status of our project. We have a total of 4 end bent columns. We're finishing up our last end bent right now. This end bent is approximately 165 foot tall, and these end bents support both the approach structures and the main span bridge. As for our towers, they're about several feet from their final elevation, so they're almost done. In terms of our precast deck panels, they're about 30% done with all of the deck panel casting. For the structural steel, this is scheduled to be delivered early next month, and then SFI is planning on assembling and then erecting around the bottom of each of the towers and building up as soon as possible.